Today we're going to talk about properties of matter and mixtures. So first up, properties of matter. What's a property? A property is a characteristic of matter that can be measured or observed. There are two types of properties. One is extensive, the other is intensive. An extensive property depends on the amount of matter that's present. An example, probably the most obvious, would be mass. If you have a glass of milk, it's going to weigh less than a gallon of milk because the glass has less amount of milk than the gallon of milk. And another would be volume. An intensive property is a property that depends on the type of matter present. The way I like to remember the difference between extensive and intensive, an extensive property depends on the amount. An intensive property is independent of the amount. Independent, intensive, they both start with I's. Because an intensive property is independent of an amount, it can be used to identify a substance. An example of an intensive property would be texture. For example, glass in picture frames. The glass is smooth no matter if it's a 4 by 6 inch picture frame or if it's a 16 by 20 picture frame. Color is another intensive property that doesn't depend on the amount. Hardness is a third example. For example, diamonds are hard no matter whether it's 1 carat or 0.1 carat. A substance is defined as anything that has a composition that is uniform, or we could also say the composition is definite. A substance is considered an element or a compound. An example of a substance would be copper. Another is table salt. A third you're familiar with would be the oxygen gas that you breathe to keep you alive. Every sample of the same substance has identical intensive properties, and every substance has a unique set of properties. So copper has a unique set of properties that differentiate it from table salt, for example. Another way to look at properties is to break them into physical properties and chemical properties. A physical property is a property that can be observed without changing its composition. An example is color, mass, or malleability. Malleability is the ability to be hammered into a thin sheet. So copper is malleable. You can take a chunk of copper, hammer it into a thin metal sheet. State of matter is another physical property, whether it's a solid, a liquid, or a gas. Chemical properties observed as it changes into a new substance. So the actual substance itself is changing. Examples here would be the ability to rust, or a substance's reactivity with acid. I mentioned state of matter. There are three main states of matter. We'll talk about these in greater depth in chapter 13 and 14 later on in the year. A solid is defined as having a definite shape, meaning its shape doesn't change no matter what container it's in. A liquid has an indefinite shape. It's going to take the shape of the container. Same for a gas. It's in an indefinite shape. Solid has a definite volume. It does not change based on the container it's in. A liquid also has a definite volume. Gas, on the other hand, has an indefinite volume. It will expand to fit its container. And finally, compressibility. A solid is not considered compressible, nor is a liquid. A gas is considered very compressible. I wanted to define a vapor because oftentimes students think it's the same thing as a gas. A vapor is a gas that has escaped from a liquid that is below its boiling point. Generally, it's a liquid or solid at room temperature. A good example that you're familiar with is gasoline. When you go fill up your car with gasoline, what you smell is the vapor itself, the gas that's escaped above the liquid. A physical change is a change in physical properties, but it still has the same composition. A physical change can be reversible or irreversible. Examples include any change of state, like melting, for example. Cutting, like if you cut your hair, that's a physical change. That's a physical change that's irreversible. Grinding solid up into a powder. And one I want you to make sure you know is physical change is dissolving. Students often mistake this for a chemical change. Dissolving is an actual physical change. For example, if you take sugar and you dissolve it in water, you're not changing the substance sugar. You're just changing a little bit about how it's arranged. When it's a solid, it's surrounded by itself. When it's dissolved in water, it's surrounded by water. And then last I wanted to talk about mixtures. Most matter in the universe is a mixture, and a mixture is considered a physical blend of two or more substances. A homogeneous mixture is uniform throughout, and it's often called a solution. Examples of a homogeneous mixture would be Kool-Aid. It's made of food coloring, flavor, water, and sugar, but if you look at it, it's the same everywhere, as long as it's mixed really well. Another example would be salt water. Looks the same throughout. Heterogeneous mixture is defined as something that has two or more phases. So what's a phase? A phase is any part of a mixture with a uniform composition and uniform properties. An example of a heterogeneous mixture with two phases would be Italian salad dressing. Has the oil layer, the water layer, and the herbs mixed in that give it its flavor. If you let it sit, it separates into two layers, the oil and the water. That would be considered two phases. Oil is one phase, water is the other. Another example would be a chocolate chip cookie. It's not the same throughout. I could take one bite and have a lot of chocolate chips in my bite. I could take the next bite and have no chips in that bite. And then finally, there are several ways to separate a mixture. Two of the most common are filtration and distillation. Filtration is when you separate a solid from a liquid. Typically, you take the liquid-solid mixture, pour it through a funnel that has a piece of paper on it. The solid stays behind on the paper, the liquid goes through, and they're separated. And then distillation is when you separate two liquids from each other based on differences in their boiling point. The most common application of distillation is crude oil, where gasoline comes from. Crude oil is a very complex, thick mixture that comes out of the ground. It's unusable. But if we heat it up and distill it, we can separate it into smaller mixtures called fractions. We can get out the gasoline that powers our car in one fraction and the asphalt that paves our road in another.